Test. Can you hear me? Can you guys hear me? Say something in the chat if you can. I think it looks like it's working from my end. But I do need to share my screen still, so hang on a sec. Okay. I don't want to keep waiting, so I'm just going to jump in here. Like I said, I think it looks like on my end, it looks like the YouTube audio ought to be working, and the Discord version both ought to be working. So let me know if you're having any issues. But I'm gonna just jump into this. So this is actually related to a thing that I'm doing at work. We're trying to log some data into a logging database, and it needs to be logged with a specific format. I'm going to approximate that here with JSON. Like this is the JSON, popular web like text format. And what we want is the ability to log random objects of any type into this database without requiring that the people who are creating these objects to need to like write a bunch of custom code. So for example, like I could in here, like if this is what I want, I could come in here and I could make a method that's like public virtual to JSON. All right, so I get my string, and then I can like, now I maybe want this down in here. And then I'd say, well, return. Need a return type in here. And let's get this indented. All right. So like I could do this, but like I happen to be, like console.writeLine c dot to JSON. Like I could do this, but I don't want, whenever somebody makes a new class like this guy here, this snake, I don't want to have to require that everybody, implement a specific for example, be derived from character. I don't want that. I don't want people to have to like think about this format themselves. Like I don't want people to have to be thinking about all this stuff. I don't want everything to be derived from character. I could, if I wanted to get around, I could use interfaces and do public interface JSON convertible to JSON. So, and then like a public, the public on the interface as string to JSON. And it's like having this interface would allow me to say, well, it doesn't have to be derived from character, just as long as it's convertible to JSON. Like I can then, it doesn't matter what the object is, I can make this work. So I could do that, but I don't want people to have to be thinking about this stuff. Partly because the equivalent of this in what we're trying to do, I want the ability to tweak it. I want the ability to change this so that it isn't doing the same thing. And like for example, if I say, well, let's change it to XML, I don't want 50 different objects to have to rework their stuff to like make a 2XML string. So I'm looking for a solution that would allow me to produce this code without the programmer who's creating, say, the snake class or the character class to have to be aware of what's going on here and have to like do extra work just to make it like produce this loggable text. So it's kind of this like weird area. I one of the things that my team is exploring is, well, we'll use code generators, and the Roslyn, since they switched to like the Roslyn compiler, it's been 6 or 8 years. It's been a little while now. With .NET Core, like the new compiler has a lot of capabilities for doing code generation. It's a much richer, smarter model, and code generators are a thing. And there is a way to, I don't know exactly what it is, but there's a way to define a new, basically to say, I want to generate the code. And so the compiler produces this method on the fly. That is much better by leaps and bounds than this version of everybody's forced to deal with this. There's a group of people who are exploring that, and I'm glad they are. I think it's a very useful thing. Like the downside to that approach is like, to make this work, you need to do something like you need to put like an attribute on here. Jason's serializable, but there is like that system.text.json. That's not what I'm looking for. So like I would create this that attribute, and this is covered late in the book, but like public JSON attribute. So you can define your own attributes. And so you can do this, and then you have to mark the class partial, which is also kind of a little weird that like, is this partial class? So yeah, okay, let me take a small step back. The catch with this code generator thing is that to use it, you need to, like, the code generation will not, like, the model they have does not rewrite code. It can only add code. So if I make this class partial and leave this off and put this on there, then it allows the compiler to come in and generate the second half of this, which would be something like this. And so the compiler will produce this based on, you like add a dependency on an analyzer that like understands this, and it is looking for any type that has this, and there's a bunch of hoops to jump through. It does work though. Like I said, the downside is there's stuff like you got to put this on there. I actually don't know, now that I'm thinking about it, I don't know how that would work with inheritance. But you know, I mean, maybe like I'm not worried about solving that problem anyway. So this code generator approach, like I said, you wouldn't write this; the compiler would produce this, and so that would mean that that somebody, aka us, we would need to write the code generator that will inspect the object and produce this, but that at compile time it ends up with this method. So the programmer who's creating this character class doesn't need to think about this like serialization mechanism or like doing this fancy thing with it. All they need to do is know to slap this thing on it and know to make their class partial, so that the compiler has the space to produce the rest of this. For what it's worth, I think the path they're going down is that there basically is like that JSON. They call that down here, I convertible to JSON. So they've basically done that so that like this is what you, as a consumer of the code generator, this is what you have to write, and then the compiler figures out how to do the rest of this. It's an interesting approach. I don't want to like dive into that because what I want to do is use dynamic method, which is its own totally different, separate beast. And that's what I'm actually interested in. So I don't like, I have seen videos of this. I haven't done it before, so I know the gist, but I don't know the details of what this is going to look like. I will say, I'm going to screw this over here. I'm kind of using this as like a guide. This is, so, I mean, how to define and execute dynamic methods. To find this, I just Googled dynamic method C#. So like I'm aware of the mechanism. I've seen videos of this, but let me like just kind of show you what it is. Like the basic idea is you define the method, and then you produce the IL instructions that go into that. And IL instructions are when you compile in C#, when you hit the compile button, what happens is the C# compiler translates your code into these intermediate language instructions, these common intermediate language instructions, which is this stuff. We'll probably look at this in a moment, but it compiles to this, which is, if you've ever done anything with like assembly, this is like a super smart assembly language. It knows about things like exceptions, and it knows about things like classes. But for example, this is a multiply instruction. This is, I don't know what that dupe does. This is a conversion to a long, I think. I'm not 100% sure. This loads the argument 0. So we'll get into this in a moment. But the idea is you write the actual assembly in quotes, like this is the intermediate language instructions, which when your program as it's running encounters a method like this, it doesn't just like evaluate these instructions. The second step of compilation happens the first time a method of this form is encountered, and it will compile this to actual hardware instructions. So if I'm on an Intel, x64, so like it's x86-64. It's the x86 instruction set with the 64-bit extensions. The compiler knows, the runtime that's running this knows exactly what hardware you're running on and can make intelligent optimizations for the specific hardware you're running on. So you get that like at that just in the moment, right when it's needed, you get the final compilation to actual like machine instructions. And when we use a dynamic method, it'll do the same thing for this dynamic method as well. So what my hope is that I can skip this attribute, I can skip this partial, and I can just have a thing that basically does something like this. I'm going to have a public class. I'm just going to keep this simple. Public static void right, and then so like theoretically, like under the current approach, I would actually just move this guy into here. Oops, why didn't that work? Cut, paste, and then oops. Okay. So yeah, again, in this case, like I would need to ensure that this is a convertible to JSON, so I can't just use an object. So this is the infrastructure that I need for either like the hand coded, like the programmer has to write this, which is kind of where I started. It's also kind of the infrastructure that I need for a this stuff, this like the code generator approach of having an attribute and then having the compiler make this. So the compiler, having the compiler make this is a huge step forward because I don't have to write this. The compiler does it. So as I'm creating an object I want to write, I I don't have to think too hard about what this looks like. It just sorts it out on its own at compile time. What I want to do is lighten the burden on the programmer so that I can basically, produce this code on the fly while being able to just pass in anything. I don't care what it is. I'm going to pass in anything. And in order to make that happen, what's this guy complaining about? I would need the partial, but so what I'm gonna do is I'm actually going to kind of put this back the way it was earlier. Something like that. All right. So what I want to do is when I encounter an object that I don't know how to log, I will generate a method using that dynamic method stuff on the fly, and then save that into a dictionary. So what I'm going to have is private static dictionary of, let's do type to dynamic method. So we'll have this collection of methods, and then what we'll do in here is we'll say if writer methods dot contains key to write dot get type. So if we have it, then we'll do writer methods. We could probably optimize this a little bit, dot. Now, in theory, somehow we'd have to probably just invoke. I don't actually know what that's. Okay, this is the invokes the method or constructor represented by the current instance using the specified parameter. So in theory, that should be to write. And I guess what I'm expecting is there to be no parameters. So I think I can get away with just empty. So I actually want to flip this around. So if it is not contained, we'll do writer methods equals generate method. And I'll write that method in a second. That's where the interesting stuff's going to be. And then basically, what did I get wrong? Oh, this needs to, okay, so static and method. Okay. Okay. So we're just going to see where this goes. Who knows? This is why it's a casual programming session, is because we're just kind of making this stuff up as we go. So the idea would be that we produce, you know what I'm going to do for the moment though? Okay, hang on a sec. Before I get into this, what I'm going to do here is I'm going to switch this to release mode for a reason that will make sense in a second. I want the optimized version of this code. I'm going to let that build, because what I actually want to see is, what does this method look like in the actual IL code? There is a tool. So now that I've built it, then that IL code should exist. And what I want to do is go take a peek at it. So there's this tool that I've got pinned here because I use it. It's hard enough to find, and I use it often enough that I just pinned it. In order to find it, so I have this tool called Everything. It's this search tool that is finds things on your computer. It's a very efficient thing. I like it better than a lot of other tools. But so the tool we're looking for is called ILDASM, the IL disassembler. So if I just search for this, then I can probably find it. Now this is like a version that's under, who knows what. But like, and apparently there's one under this paint.net. I don't know what that is. This one looks good enough. So like if you want to find it, like you could probably dig around and find this ILDASM, the IL disassembler. But it's like this one would do it. It's part of the SDK that you get. Like it's around. Like you can find it. And if not, you could probably download it separately. But it's a kind of. So I'll open it up here. It's kind of a. I don't have a better word to describe it other than podunk. Like it's kind of this like. I don't know. It feels like it was made in like 1995. But it definitely does the job. So I gotta just find, hang on a sec, let me figure out where this guy is. Nope, that's not what I was looking for. I want open in, I swear I just want to know where this is. Okay, here, and now if I go to here, so I can come in here and I can see in the bin folder, I'm going to go to the release version, .NET 9. And so I'm now, like, what I'm looking for is the compiled code, which is this sandbox misspelled because somebody 3 weeks ago was asking about how you rename projects, and I've never named it back. You want this DLL one, and I'm going to say open. And now I can come in here and I can see what got compiled. And like, so writer, like here's this generate writer method. Like these are the IL instructions for that method. So I can just come in here and find the thing I'm looking for. One of the things about this is it's like when you first dive into this world, like this is a lower level than most people are used to with C#. But I think this is the kind of thing that is like this kind of stuff helps you understand the code you're writing a lot more thoroughly because you're able to see just exactly what this stuff does behind the scenes. And I think that's really valuable. It's not the kind of thing that a brand new, somebody new to C# needs to be, needs to master. But I do think that as you get more experience programming and as you get more experience in C#, like eventually coming down to this level is really, I think it's a good idea, especially if you're like sitting there saying, well, I don't know what else to explore. Like you can follow the things that are interesting to you, but I definitely think that understanding the pile of stuff that your code is built on top of, how, .NET, the runtime works, how this thing gets compiled, how garbage collection works. I mean, even how like assembly, like actual, like the final like x64 instructions work. I think those are very useful for programmers. Most like university, like 4-year degrees, like if you get a bachelor's degree in computer science or software engineering, they typically have a couple of classes on like how the hardware actually functions, and you deal with flip-flops and like the circuitry and like AND gates and OR gates and some of that stuff. But there's also usually another class that's like, we're gonna write assembly. It's usually like, for example, the class that I had was MIPS assembly, which is MIPS is not simple, but it's simpler than x64. And so it was like as a chance, like, and we wrote assembly code. So all this like lower level stuff is definitely worth getting into. But I will admit that like if you're in chapter 9 of the book, like this stuff might be overwhelming, and that's fine. Like when I first looked at this stuff, I was super confused what it was, and I had to sit here and Google a million different things. Before we're done here, I might be Googling a million things just to figure out what we're doing here. But more of this makes sense to me now than it would have 10 years ago or 20 years ago, right? Like this is, I've done this kind of stuff enough that I have some, I would not call it expertise, but familiarity with it. It's not such a strange world for me. So for example, like .ctor, that's the constructor. The cctor, that's the class constructor. So this is the static constructor. So anyway, like I can come in here and I can find this stuff. What I want actually is I want to come in here and I want to find, oh, by the way, like these. So I think this is interesting. How do I don't want to be in here anymore. This is the kind of thing that I always find interesting. So character, I have max HP and current HP, and in doing this, we just made auto properties. But when you dig down into this level, you can see this right here. These are fields, the little blue square. These are fields, and you can see that it generated this, and you can see the name that it generated. It's an awkward name, like less than current HP greater than K underscore underscore backing field. Like this, that's not a valid C# identifier. You could not actually type that if you wanted to and have it work for anything. But that's what the compiler made, and like here's the actual implementation for these get and set. Like, so it's really interesting to dig down in this level and see like what does the compiler do when I do this. But again, like if you want to see this, like it's just you can see exactly what it does. And like this is it's a method. So these getters and setters are like for properties are straight up methods. Anyway, what I wanted to do is crack open this to JSON and try to inspect this and see what it's going to take for us to recreate this. And this is not simple. Start with that. And it makes me wonder if like we can make our our dynamic method mirror this, but it's like let's see if we can just pick through some of this stuff. Let's see. This is load. Okay, so one thing I should mention here is that, so in the book, it's like the last chapter of part 1, I talk about like the stack and the heap and how that works. What's interesting is that at this IL level, it isn't like the model that it has is a stack based machine. And so it actually like, it doesn't, things are a little different than what the book describes at this level, because we haven't made the final compilation to something that the actual computer can understand. And what happens is there's the stack of information that you just like pile values on. And so like if you want to add 2 plus 3, you would say load a 2 on, and then you say load a 3 on, and then you say add. And what that will do is it'll take the top 2 values, remove them from that stack, compute the add 5, and then place that back on the stack. So if you want to like add 3 things, if you want to add 1 plus 2 plus 3, then at this level as a stack based like virtual machine, you put the 1 on, and then you put the 2 on, and then you put the 3 on, and then you say, and then the next instruction would be add, which pulls the 2 and the 3 off the top and puts a 5 back on it. So now there's a 5, and underneath that there's the 1, and then you do another add, and it pulls the 5 and the 1 off and puts a 6 back on top. And that's at this level, that's how it works. So you kind of have to understand that to know what this is doing. But again, like off the top of my head, I don't. So this is loading onto the stack a local, and like I said, just we're going to figure this out as we go. But the idea would be that we want to like we want to just kind of dig through this and figure out like how we would recreate this. And I will say this is the major downside to this dynamic method approach, is me as the guy who has to end up writing this, I've got to understand how the IL instructions work. My hope is by me taking that burden on, I can lighten the load off of programmers who can then just say, you know what, just write. So they can just say, I'm just going to give you an object. They don't have to think about it. They don't, it could just be any old object. They don't have to have this toJSON method. Like they don't need to do any of that stuff. Now, before I go any farther, I actually want, I want to make this as simple as possible for me for the moment. This is more proof of concept than anything. And maybe what I want to do is something like this: return max HP plus comma plus current HP. So let's, instead of trying to use full JSON, let's, we'll just remember the order, and like we could do something else with this, but like let's make our life simpler. So this is technically toJSON. It's not anymore, but like I said, I just want to, because I don't, like I said, I looked at this and like, it's a little intimidating. There's a lot here. And like, I see like, this is just a method call, but like some of this, like it's got all this default interpolated string, like it's got a lot of stuff in here, right? I'm trying to explore the dynamic method space without panicking myself about everything that's going on here. So let's start with something simpler, and then maybe I only plan on going for another till 3:30 my time, so another 28 minutes. That's as far as I plan on going. So I'm not going to get that far in here right now, which is totally fine. But let's see. So I want to recompile, but that means I got to close this because they will. This guy wants to lock down the DLL. So if I got to close that so that I can recompile, and now I can come back in here and open that up again. It should remember where I was. So for what it's worth, there's an option in there that's like open as read only. I thought that might make it so that I could just recompile, but it really doesn't seem to. I don't know why, but anyway. Yeah, so this character class. So now we can maybe look at this toJSON method, and maybe it'll be simpler, a little easier for us to wrap our brains around. And I'm going to start kind of like Googling some of these. So let's see. So load argument 0. This, so I kind of want to, yeah, I want to double check this here. So instruction pushes the argument indexed at 0 onto the evaluation stack. So argument 0 in this case, where did that go? So this is interesting. Argument 0 is the object itself. This is one of those there's static methods. But what's interesting is that behind the scenes, every method effectively becomes static. What it's like, and if you've done anything with like extension methods, like you can make a public static class character extensions, right? So if you make, again, this is covered in the book in like part 3. If you want, like you could, so I have this method that's here, but you can add an extension method to a thing, and the first parameter in here is the object that it's supposed to be applied to. So with this defined, even if I didn't have this, like if I just move this down to here, in theory, so now I got to do character dot max HP and character dot current HP. So even though this is defined as a static method, and normally you would do something like character extensions dot toJSON C, right? Like normally that's how you'd call a method. Because it's an extension method specifically, you can do C dot to JSON, and the compiler reworks it into this. Well, it turns out that's essentially what's happening for every single method call ever. So in some ways, it's kind of like, well, extension methods are just kind of exposing these details. But basically, in short, whenever you have an instance method, what you end up getting is the first parameter will be the object itself. So it's not shown here, but when we look at it at this farther down level, that arg0 is this. It's the object we're inside of. So that says put the object on the stack, and then call this get max HP method. So that's essentially pulling, like it's calling this right here. And then this says store that in local variable 0, which is find here. So this has made a, even though like we didn't declare a local variable, basically it's rewriting this to something like string, or well, it's not even that, it's an int. So it's like, so it has called this v_0, but its type is int32. That isn't a 32-bit int. That's the int type. Like we know it as int. So it's basically saying int, like it's called at v0 equals max, this dot max HP. So like it's effectively done that right there. And then this says, so let me put it this way. When we do this, our stack ends up looking like, is there a way to pin this to the, no, that's annoying. I want to see both. Just don't need it to be so big, do I? By the way, there's like a thunderstorm passing by. I doubt you'll hear the thunder, but if like all of a sudden the stream just dies, it might be because I lost power or internet or something. I don't think that'll happen. It sounds like it's fairly distant, but who knows? All right, so yeah. So if we're analyzing this like in terms of like a stack, I'm gonna just come in here and say, so imagine we have a stack and it grows to the right. We say, so load argument 0, so we throw this on the stack, and then we say call that, and all of the method parameters, including this, gets pulled off the stack, and what gets replaced is the return value. So that would be, I think this was like max HP was 15. So like now our stack, like, so this gets put on the stack. When we call that method, this gets stripped off. We call down into that method, and then when it returns, the return value gets put back on the stack here. So now our stack looks like that. And then when we say store into this line here, store into local 0, that just removes this from the stack. So now our stack is empty. So again, you kind of have to understand this like stack model. I'm just going to start piling stuff up on here. And then now it says load this local back onto the stack. So now we put that 15 comes back onto the stack. And then we call toString. So again, like this gets removed as we make that call, but it gets replaced with the return value, which is the string 15. And now it says load string. So that's just loading a literal string onto the stack. So it says put a comma in there. So now there's 2 items on our stack. And then this loads argument 0. So again, now this goes back on there. So it's interesting that it's willing to pile this stuff on. But okay, so anyway, and then it says call that to get the current HP. So this comes off, and the current HP gets put on there, which I think was 10. And then we say, so that's this call. And now it says put that 10 onto the so it says take that call. Yeah, let's see. Store that back into local 0. So it's the same like v0 that we were seeing. So this gets put in v0, which is an int. And then and now it says, okay, now pull it back on. It's kind of like, I don't know that it feels weird that it felt the need to store this here and then pull it back on. And there might be a very good reason for it that I'm just not aware of, but like, anyway, so now it says we'll put that back on there. So copy it back out of the local variable. It's like, I don't feel like it needed that, but there might be a reason that I'm not thinking of. And then now it says call to string, so that to string removes this, and then the return value gets put on there. We get that. And then our final line here is concat string, string, string. So a 3-parameter string. That is this, this, and this. So all 3 of these get removed and replaced with this string concatenation with those, which eventually gives us 15, 10. And that's what's on the stack, and then we return. And because this is sitting there at the top of the stack, when we return, that is this method's return value. So at this IL instruction level, like you have to, IL instructions are their own thing from C#, and they're also their own thing from like the actual compiled instructions. So it's a yet another like model to think about and understand. It's some interesting stuff, but that's how it works. And we could recreate this. I think like we could recreate this. The concern I have is that if I have more than that, I'm not going to end up with, like if I do want to get this length in there, is there a 4-parameter string concat? Let's look it up. Oh, I've got this here. And well, there is. It looks like there is. There's a 2-parameter string. We just saw that there should be a 3-parameter one in here. Where is it? String. There's a 4-parameter one. Obviously, at some point that must end, and eventually you would just use this. So long term, this is more what we ought to go for. But all right. So the idea here is what we do in here is we'll build the equivalent of this method dynamically. And I think that's not going to be, given the time we've got, I don't think I'm actually going to finish it. And, I mean, that's okay. But all right, let's, well, first of all, the first thing we need is, let's see. So dynamic method has multiple parameters. What are they? So it's a name, which like, I mean, like we could call it toJSON. That's what the method was called before. The way we're going to use this, I don't think we are going to care about what this looks like. And then what's the next parameter here? So the return type. So this would be, return type is string. And then the parameters. And I think the one parameter that we want is, so it needs to be an array, but this would just be target type. So basically what we're trying to do is create the equivalent of a method that looks like this. Like in this case, it'd be essentially we're trying to create that. It has one parameter whose type is that. This needs, okay. The example has another thing, the system.reflection.module. And I'm going to be honest, I don't know what a module is in this context. Like I've heard that before. I don't know what a module is. Like their thing, what they've done here is they've said type of, and then like that. Okay, and this actually gets the module, the DLL, in which the current type is defined. So this is weird because like it's not we're building this on the fly. So it's not like it was actually defined in that DLL. Like if you go look on disk, it's not there. But in theory that works. And then, okay, so first, rework that, and then I'm gonna do that, but somehow I need to get these IL instructions in there, which should be something like, I'm looking at that sample again, and this has IL generator, like I get how to do that, but I don't know how, oh, never mind, I just saw it. This, okay, I think we're okay. So this il.emit, and now we can start making our stuff. And I mean, that's going to be it in a nutshell. So I can start by saying il.emit and then load, opcodes dot load R0. So again, remember that is that's the thing we pass in. Actually, now that I'm looking at it like this, in this case, invoke, I think we need to pass in that. All right, we got to pass in the object. Okay. All right, so we load that, and then like essentially what we want to do is something like this. We use reflection to find all these things. So target type dot get properties. And like we could also expand this to be fields, but I'm not. Right? So now we're bringing reflection into the mix. So again, reflection actually it's notoriously, like it has this reputation of being slow. And that is true. We could, in this case, we could do this whole thing without making a dynamic method and just use reflection. And just like like with this reflection, like you can say property dot like property dot get value. Don't want that. You can just basically like call that, and like we could do this using reflection. But like I said, it's notoriously slow, and I'm gonna put a big asterisk on that. It's slow in the sense that like it might be 5 or 8 times slower than if you just hand coded it yourself. But that means that it'll take 20 nanoseconds instead of 4 nanoseconds or something. In most cases, it's probably fast enough. So don't panic too much about reflection. If it's the right tool, I just though the catch is it's reflection code. It's got like it's anyway. I won't go any further into it than that. But anyway, we are only using reflection to build a method on the fly. to be able to build this method on the fly. And so, like, well, one thing I could do here is I could say il.emit. Like, we already see these instructions over there. Like, we could just like write it all, and maybe that's a good starting point here. That if we wanted to just not use reflection, so I'm gonna like we do want that. We want to be able to iterate through that and just get them all. But it might be easier for us to start with. To just start with trying to recreate this, you know. So call, and then this is, so I'm not sure what the syntax for this is going to be. So I'm going to look that up too. File generator emit method call. I want to see an example of this before I. There is this emit call method, and I wonder if that's the right option. Because I feel like that right there is what like we're expected to have. So if I do emit call and then do method info, actually, like in this case, property.get method, this is the method info we want. If property.get method is not null, got 7 minutes. I'm gonna run out of time. I do see an example in here that just has emit with call, and it doesn't have specifically. Call a bar args method. I think we need that. We're not using bar args. All what did this need? Get method. Something like that. So that's the equivalent of this right here. And then we can do il.emit opcode.store. So that'll store it into local 0. Except that, like I said, again, I wonder, like, then the next thing that this does here is it loads that local back in. And I feel like I would be better off il.emit just jumping down to rather than storing it to local 0 and then loading local 0, to just call this. I mean, it's saved, like this version has it saved off, which could be nice, but it stomps on it down here with another value. So now I need a type of int.get method to string. That shouldn't be null. So we'll call toString, which should take this value off of the stack, and when it returns, it'll come back with a string on top of the stack. And now if I want to save anything off, it'd be this. However, maybe given that I've got 2.5 minutes left before I need to be done here, maybe what I should do is just il.emit opcodes.return. So I'm gonna skip all of this loop. I'm gonna do that. I'm gonna do get property. Type of character. Get property. This needs 2 parameters, doesn't it? Oh, no. Just had this. I mean, is it? It's a okay. So I'm putting these exclamation marks in there to say assume it's there for sure. That's maybe the place to do it. Oops. Okay. That question mark on. So if we just say no, it better be there. I know it's there. So that should theoretically get the thing, return it, and then so theoretically what we've done is we have said assume it's a character, get this max HP property, get its getter, pull that out. So we call the getter, and then we assume that it's an int, and we call toString on it, and so now we have a string value, and that's what gets returned. So like this is a very poor version of it because we did not iterate through the properties. Like there's a million things that we're missing, but I feel like if we did it right, we actually ought to a very thin slice of what we would need. This would theoretically we should have built enough of this that it should display the max HP in string form, which should be 15. So if this works, we will have generated the method that'll get them 15. I'm going to run this, and we're out of time. So regardless of whether it works or not, this is probably going to be it. But the good times. Let's see what it does. Build failed, but I don't think that's specific. Oh yeah, I don't think that's because of the code that I've been writing. This is because exceed the recount. That's because I've got it open over here. Debugging. Debug. I told it to debug even though it was in release mode. Ambiguous match for int32 system.string to string. I probably, if I were taking a guess, I'm going to guess there's multiple overloads of that. Yep, there are 4 of them. So we need to specify the parameter list. Which is the no parameter, the empty one. It detected an invalid program. This exception was written in front of the stack. Yeah. So somehow these instructions do not make for a valid program. I do think that the gist is correct, but it's possible. Oh, you know what? And it's possible that it's this. We said store into local 0, and yet that's what I'm looking for. I if I were taking a guess here, it's that it's that I missed that, and I think right. So it needs this v0, and I'm not sure how to do that either. Opcodes, load lookup. Want an example. So I do so. The following emit method overload can use the load loca opcode, and it has an int 16, so it's short. And I wonder if I say I do that. However, okay, I wonder if I need to do something to say you need a local variable. But the other possibility here is, why do that? Like we had talked about that, right? Like why? Well, I got something different at least. All right. I mean, I'm 6 minutes over the time I wanted to do. So I'll wrap this up really quick. I think the takeaway is um, this is kind of an interesting space to tinker with, but definitely trying to manipulate IL instructions can be difficult. It is one of those things that, given what I'm trying to do, I might be able to just get the thing solved and then not have to think hard about it. Because what I'm trying to do is I'm willing to pay kind of a high cost so that people can just like write a character, write a anything. Like they in theory, you ought to be able to say something like writer dot write. Um, I mean, heck, even something like this. This is a what's this called? It's an anonymous type, right? So it is like this is it's a type that's fabricated on the fly, and that it could just work. Or I could do something like this where I just say 2, 3. It's a tuple, and it just works. Like I don't have to do anything fancy to make this work. That would be the hope. Um, but at what cost? And is this cost worth it? So I think the answer to that question depends on how much headache it'll take to sort through this. And right now, I don't have time to do it. So maybe we'll pick this up in a week. Of course, maybe by a week from now, this problem will have been decided. Like I said, my motivation for this is primarily a work-related thing that I want us to consider this option in addition to the other like 3 or 4 options that we've looked at that might be equally valid. So I may or may not pick this up later, but yeah, like I said, interesting, like weird, deep, dark caverns of C sharp. I think that makes it fun. So don't get too many chances to do this type of weird stuff, but so enjoy the weirdness while you can. All right, that's it for me this time. So I'll catch you guys next time I do this, which I don't know if that'll be next week or 3 weeks from now or who knows. But thanks for joining me. I'll see you guys next time.